Okay, we're going to solve some absolute value inequalities. These are kind of complicated and they get confusing. In some problems you're asked to solve them, and some problems you're asked to graph the solutions. So my recommendation is to always graph, even if you're only asked to solve. I think the graph, the number line, really helps you understand what it is that you're doing. If you don't understand what you're doing, then often you'll try to memorize a procedure, and these are so complicated and so different, each one is so different, that memorizing a procedure is going to lead you into some confusing trouble. So understanding what's going on is the best way to go, and then you don't have to memorize anything, and you always know what you're doing. And I think the number line really helps. So let's look at this one. This one says to solve 6 times the absolute value of x minus 9 plus 4 is less than or equal to 28. And it doesn't ask you to graph anything. It doesn't say graph the solution. However, I highly recommend drawing a number line as you go to kind of see what's going on. So the first thing we want to do is you always want to isolate the absolute value. Get rid of everything else on the left-hand side so that you just have the absolute value part. So the first thing we want to do is get rid of that plus 4 by subtracting 4 from both sides. And then we're left with 6 times the absolute value of x minus 9 is less than or equal to 24. And now to get rid of the 6, we just divide both sides by 6. And now we've isolated the absolute value. So we've got the absolute value of x minus 9 is less than or equal to 4. So let's recall what that means. Remember, I told you to always think about absolute value of something as the distance that something is from 0 on the number line. So the thing inside our absolute value is x minus 9. That represents some real number. And it has to live a distance of less than or equal to 4 units away from 0. So it's no more than 4 units from 0 on the number line. So let's look at the number line. Starting at 0, there's 2 directions, right? We could go to the right 4 units, and you land at positive 4. Or you could go to the left 4 units and land at negative 4. So the thing inside our absolute value, x minus 9, is somewhere in between negative 4 and positive 4, because it can't be more than 4 units away from 0. So that tells us that to get rid of the absolute value, which is our goal, because we want to solve for x, so we can't just take away the absolute value. We need to know what to write instead. So in this case, we know that to take away the absolute value, all we have to do is say that x minus 9 is somewhere between negative 4 and positive 4. So we write x minus 9 is less than or equal to positive 4 or greater than or equal to negative 4. So it's a nice compact compound inequality. And those are really easy to solve. We can treat it like a single inequality. So we want to isolate the x. We want to have the x in the middle all by itself. So we want to get rid of that minus 9. So let's add 9 there. And that means we have to add 9 there and there as well. And so we're left with just x in the middle. And we've got 5 less than or equal to x less than or equal to 13. So there's our solution. X is in between 5 and 13, or equal to 5 or equal to 13. That's our solution. But what does that look like on a number line? If it asked us to graph it, we would have to do this. So there's my number line. So x could be equal to 5 or equal to 13. So we can plot solid dots at 5 and 13. And x can be any number in between. So we're going to draw a solid line in between 5 and 13. So the solid dot at the number 5 means I'm including 5, and the solid dot at the number 13 means I'm including 13. And then the red line, the solid line in between, means I'm including all those numbers in between. So that's our solution. So the key here was that we had to isolate the absolute value. So we isolated the absolute value. We got absolute value of x minus 9 less than or equal to 4. And because of the less than or equal to, that allowed us to picture it on the number line and see that we could take away the absolute value and write this nice compact compound inequality with no absolute value at all. We could say x minus 9 has to live in between the numbers negative 4 and positive 4 because of that less than or equal to. And if it were greater than or equal to, it would be a whole different ballgame. So it would look entirely different. So let's look at an example with greater than or equal to. Okay? So here's another inequality, absolute value inequality. This one says the absolute value of 3v minus 9 is greater than or equal to 3. So it's not less than or equal to, it's greater than or equal to. So we've already isolated the absolute value, so we don't need to do anything. So now what we'd like to do is take away the absolute value, but we need to know what to replace it with. So let's picture it on the number line. So here's my number line. So the thing inside the absolute value, 3v minus 9, is just a real number that has to be at least 3 units away from 0. It has to be greater than or equal, a distance of greater than or equal to 3 units away from 0. So there's two directions, right? We can go to the right. So we could be at 3, positive 3, or beyond. We can't be between 0 and 3. We'd have to be at 3 or beyond, greater than. Or if we go to the left, we'd end up at negative 3 or beyond. So we're either way out there or way out there. We're not in between. Because of the greater than or equal to, we can't say that we're in between negative 3 and 3. We have to say we're beyond negative 3 and we're beyond positive 3. So how do we write that? We want to take away the absolute value. We have to write a compound inequality, but it's not a compact one. So we have to say that 3v minus 9 is less than or equal to negative 3, or it's greater than or equal to positive 3. Okay, so we can no longer write it in between the two numbers. We have to write two different inequalities, one saying that it's less than or equal to negative 3, and the other one saying it's greater than or equal to positive 3. And we had to write an or, not an and. Why is that? Well, if we said and, then what we're saying is we have a real number, 3v minus 9, that is both less than or equal to negative 3 and greater than or equal to positive 3. And that's obviously impossible. We can't have something, a real number that's less than or equal to negative 3 and greater than or equal to positive 3. So that's why we have to say or. It's either one or the other. So now we can solve these separately. So the first one, we just want to add 9 to both sides. And we end up with 3v is less than or equal to positive 6. And then we want to divide both sides by 3. And because 3 is positive, that means we do not have to reverse the inequality. So we just end up with v is less than or equal to positive 2. We didn't have to reverse the inequality because we divided by a positive. The other one, we do the same thing. Add 9 to both sides. We end up with 3v is greater than or equal to 12. Divide by a positive number, positive 3. We don't have to reverse the inequality. And we end up with v is greater than or equal to 4. And it has to be an or, because there's no way a number can be less than or equal to 2 and greater than or equal to 4. That makes no sense. And so the instructions asked us to graph this solution. So we're not quite done. So let's draw a number line. And now v is less than or equal to 2 means we plot positive, v is greater than or equal to 4, sorry. We plot positive 4 with a solid dot and draw the arrow off to the right, going in the positive direction. And then we draw another one at 2, and the arrow going down to the left, because V would be less than or equal to 2. Okay, and there's our solution. So the key here was that when we isolate the absolute value, we have the absolute value of something is greater than or equal to a real number, a positive real number. That means that we're going to have to break it up into 2 inequalities. So we get a compound inequality. One saying that the thing inside the absolute value was less than or equal to the opposite of that positive real number. So in this case, less than or equal to -3. And the other one saying that the thing inside the absolute value has to be greater than or equal to that positive number. And then we solve those two separately, and we have an or statement, because it's impossible for a real number to be both of those things at the same time. And then we plot. And that's that.